some other work about massively multilingual work from my lab. This was published at LREC 2020. The tool is called a WikiPron. It was developed by people mostly out of my lab, but also with my independent scholar colleague, Jackson Lee. Speech technologies like automatic speech recognition and text-to-speech synthesis require mappings between written words and these pronunciations. However, these mappings are expensive to create and maintain, and free, large, high-quality dictionaries are only available for a small number of these languages. Also, for open vocabulary style applications, these mappings need to generalize to unseen words. So if you're making a very small system that handles the weather or something like that, maybe you can cover the full vocabulary for the task. But if you want a system that does generic text-to-speech synthesis, you have to make it generalized to unseen words. It's often possible for a literate, linguistically sophisticated native speaker to just write out all the rules. But rule-based systems are brittle and difficult to maintain, and are often outperformed by machine learning techniques. So for instance, in Van Esch et al. 2016, which is a paper at Interspeech or ICASP, I forget which, a team at Google took a bunch of rule-based pronunciation systems they had lying around and then just compared them to their, like a generic off-the-shelf LSTM sequence-to-sequence model trained on the lexicon. In almost every case, the lexicon handily outperformed the rule-based systems. Now, we can mine this data. Once again, just like UniMorph mines morphological paradigms from Wiktionary, we can mine pronunciations from Wiktionary. So here's an example for the word decimate. You can see here that there's a little box here that has an IPA pronunciation, and it's labeled as received pronunciation. We also have an English pronunciation down here, which happens to be identical. It's not quite identical. There's a difference in reduction, sorry, in the reduced second syllable. Wiktionary has previously been used to mine pronunciation data. So I know a couple of papers here by Schlippe et al. This is, almost more than a decade on now. They extract Wiktionary pronunciation data for 4 languages that they were interested in: English, French, German, and Spanish. They say the data is abundant, and once they do some stuff, they use it for data augmentation in a speech recognizer, and it substantially improves performance. However, that paper has no software, no data. So while their effort was it was a nice demonstration that this works, it's useless to us if we want the data. Derry and Knight in 2016 actually released their collection, which they mined from Wiktionary, and they've got more than 500,000. Unfortunately, though, they didn't release the software. When I followed up with Olia Derry, she said, oh yeah, the software was just a mess. That's why they didn't really release it. It was very hackish. So we wanted to do this with good software engineering principles and develop a tool that could be reused. And when we say reuse, we want to take advantage of improvements to upstream to Wiktionary itself. So hence WikiPron. It's an open source Python library for mining pronunciation from Wiktionary. But you don't have to know how to use a command line Python tool to use WikiPron, because you also can just take advantage of what we call the big scrape. This is a database of, last time I checked, 1.3 million word pronunciation pairs in 337 languages, dialects, and scripts, living and dead. This big scrape is refreshed roughly twice a year by our lab. In fact, I'm doing a refresh right now. It's actually very simple. You can run just a handful of commands and simply wait about 2 weeks and you get the new scrape. Then all you have to do is simply push out a pull request and we have updated the database. We try to do this about twice a year. We've done this, I don't know, 4 or 5 updates at this point. So once again, we have to deal with some interesting complexities here. You see that there are sort of broad and narrow transcriptions. There's also dialect information present in the entries here for this word, for given words. This is the word here is gorilla. Down here we have yamar, a task to be called, excuse me. We also have to distinguish, I mentioned narrow versus phonetic transcriptions. I don't want to call these phonemic versus phonetic because they're not. I'm a linguist and I can tell you whether you're doing it right or not, and the Wiktionarians are not doing it right. That's fine, but they do sort of track with what I would call narrow versus broad. We also can control whether we have stress marking, syllable boundary, or tones. We can choose to segment the transcriptions or not. We have a library for that. So there's sort of a common sense way to segment a transcription, to chunk it. So like we want to treat the aspiration on the K as part of a feature of the K. Our chunking library understands that. We can also target a specific dialects. We also can choose whether or not to case fold the head word, depending on the language. So our procedures when we run this big scrape generates big tables that look like this here. So you see like for Afrikaans, we have broad and narrow transcriptions, for instance. These tables are huge. It automatically generates this table as a side effect of our scraping procedure. By default, all words are case folded and all transcriptions are segmented with stress and syllable boundaries removed. That's usually what we want. We also do post-processing steps that include like splitting languages that appear with multiple scripts. So for instance, Serbo-Croatian is treated as a single language in Wiktionary. So we simply split it on Cyrillic versus Roman. We also can do various forms of filtration on these files, which are just TSV files, tab separated value files. The filtering in question is usually based on the phones used. So for instance, the English pronunciation for the word Bach includes a hyper-foreign pronunciation, Bach, which of course is very rare in English, but something one can do if one wants to be pretentious. You just said Bach, the K. We handwrite lists of permitted phones, and then we filter out things that are not in those, that are not entirely drawn from those phone lists. So for instance, our filtered version of English excludes this form because the ch phoneme is not a phoneme of modern English. There are many hyperforeign pronunciations that are also just typos that get filtered out by this procedure. Here's what a phone list looks like. This is for Latin, I can tell just by looking at the list of phones. These are all the phones you recognize. So you see at the bottom, we have like phones that only occur in Greek borrowings, like the aspirated stop series and u, excuse me, and z, none of which are phonemes of Latin per se, but occur in Latin words that have been borrowed from Greek. Most languages on Wiktionary use the same underlying HTML structure for the pronunciation portion of their entry. Those that don't require bespoke extraction functions. Changes to Wiktionary or the underlying HTML of particular languages on Wiktionary leads to scraping failure. So we have to go back and build basically bespoke scraping functions for individual languages. This happens quite a bit. But we do quite a bit of reliability engineering to detect these kinds of drifting too. We have extensive continuous integration testing that runs using like GitHub webhook integration. So we do build, we test, static type checking, we lint, and we reflow, all automatically. And this allows us to handle contributions from quite a few people we've never even met. We do have quite a few contributors now. And finally, the workflows produce human readable tables and TSV summaries of sort of the scraping procedures as a side effect. That's kind of a nice feature, is it automatically summarizes the data for us as part of the workflow. Current development procedures include phone lists and the addition of subdialect flags and methods for handling dialects within dialects. These so-called subdialects, sometimes it'll say something like Brazil dialect, but it'll also say Sao Paulo dialect of Portuguese, for instance. That'll be treated as a subdialect. We don't quite have code ready to handle that particular approach. We're also, we want to have more testing. One thing we can't do very easily is detect large-scale changes to scrape, how like a large-scale change will affect the scraping procedure itself. Like if I change a line, will this cause everything to blow up? We often don't know because we don't know, because our tests are only in certain languages. And finally, we're also doing upstream improvements to Wiktionary itself. I am particularly focused on improvements to English Wiktionary, for which the pronunciation quality is horrendous. I have a work study, if you know what that is, working on this summer.